Hello, everyone. Today we are going to be talking about evaluating trig functions, which we've already done, but we're going to be able to do it now of any angle that we see. And we're going to kind of combine our knowledge of both right triangles and finding angles on a coordinate grid. And we're going to use that to our advantage to find different measurements of angles. So one of the first things that is going to be really helpful to us is to find something called a reference angle. And really a reference angle, what it technically is it's the angle that is made with the x-axis. So depending on where your angle is, let's say you have your little mini coordinate grid. If your angle is in the first quadrant, it just means that we kind of think of that more of as a right triangle. And this angle right here would be what we would call the reference angle. If we're in quadrant 2, this just means this angle would be what we would call the reference angle. If we're in quadrant 4, it would be this angle that would be called the reference angle. And quadrant 3. And if you're in quadrant 4, this angle would be called the reference angle. So just like we've kind of been practicing the last couple of days, we're first going to go ahead and find our angle on the actual grid. Now, you can kind of do this one of two ways. If you're like Miss Hardy, I am not always a fan of working with negative angles. So one thing that I will always do is I will find the coterminal one that's positive. So if I add 360 to this, 295 plus 360 ends up being 65 degrees. And that angle is much easier to find on our grid. And the awesome part is, drew that a little close. When I go and find my angle, remember, my initial side is always on the 0 degree positive x-axis. So if I'm going to go 65 degrees, that is less than 90 degrees, obviously. So we're going to be somewhere in quadrant 1. And that angle right here, 65 degrees, is our reference angle. So because that's the angle that's made with the x-axis. Now, if we look at like example C, for example, now here, again, I'm going to find a coterminal one that's a little bit smaller. So if I work my way around, if I go minus 360, that's going to give us 340. And if I subtract 360 again, no, not again, but if I find 340 degrees, let's see where this one falls. So if I look at my mini coordinate grid, obviously here, if I go all the way around, this one would be 90 degrees. This angle would be 180. We're obviously more than that. This one would be 270, and all the way back around would be 360. So 340 would fall somewhere right in here. Now, 340 isn't my reference angle because that goes from 0 all the way around my circle, all the way to this angle right here. This angle is 340 degrees, and that's not the reference angle. The reference angle is the angle that's formed between our angle down to the x-axis. So here we have to use something else to our knowledge. If I know that I've gone 340 degrees all the way around, and this angle here would take me to 360, well, 340 is 20 degrees away from 360. So our reference angle would be 20 degrees. So it really just kind of depends on where the angle is going to fall. Now, if you're working in radians, you have kind of one of two options. You can either convert this to degrees, which is actually what we are going to do first. Now, to convert to degrees, this is where we have to multiply by our scale factor, which, if you will remember, to convert from radians to degrees, that is, we multiply by 180 over pi. So if we multiply my numerators together, this is 7 times 180. That's going to give me 1,260. On the bottom, 12 times pi. I'm going to leave as 12 pi. And then all we have to do is take 1,260 divide by 12. And now here, I forgot to mention, right? There is still a pi up here. The pi's are going to cancel, which is why that's all you have to divide. 1,260 divided by 12 gives us 105 degrees. Now, to find that angle on my grid, we are going to first go say, okay, well, I'm definitely more than 90 degrees, but I am less than 180 degrees. So when we go about finding our angle, I know I'm somewhere in here. 105 is probably a little bit closer upward towards the 90. But the key is that this is not our reference angle. That's not the angle that's made directly down to the x-axis. This angle would be the reference angle. So we can use the fact that halfway around is 180 and we're only going to 105. So all we have to do is take 180 minus 105 to find out what our reference angle is going to be. And that angle is going to be 75 degrees. So that is our reference angle. So depending on where your quadrant falls, it really just kind of depends. Let's do one that falls in quadrant 3. And you'll know that because if I, first of all, I'm working in radians. So if I convert this to degrees, we're going to multiply by 180 over pi. So my first step is obviously going to be to multiply 11 times 180, which is 1,980. Bring the pi with it. And if I take 8 times pi, that's going to be what's going to chill on the bottom. So my pi's, the awesome part is those are going to cancel. And all we have to do is take 1,980 divided by 8, which does turn out to be a decimal, but that's okay. It's about 247.5 degrees. So if I find that on my grid, that's obviously definitely more than 180 degrees, but it's less than 270. So my angle is going to fall in quadrant 3. But again, we have an issue because this angle right here is 247.5 degrees. Our job is going to be to find the reference angle, which just goes down from my angle to the nearest x-axis. So here, probably an easier way to go about this is really going to be taking 180 minus our angle of 247.5 degrees to give us what that angle right there is going to be. So now typically we probably should switch this around because, right, if we look at 180 degrees is less than this, but if I subtract those angles, 247.5 minus 180, that's going to end up being 67.5 degrees. And that's going to be my reference angle. So you're going to start to notice that your reference angle, obviously, if you're in quadrant 1, like the first problem that we did, this one, the reference angle is always going to be whatever the angle is. Anytime you fall in any of the other ones, quadrants 2, 3, or 4, these you're going to have to do a little bit of extra work to figure out what that reference angle is going to be. Now, I'm going to come back. There's a section kind of below this that I'm going to come back to. And the first step that we're going to do is, this is the ultimate goal for today, which is to be able to evaluate any trig function out there in the world. Because typically we do this with our knowledge of kind of some special angles, but the idea, though, is that if we're going to evaluate any trig functions, we can actually go through and use, first of all, our knowledge of coordinate grids, but also our knowledge of trig functions to help us answer these questions. So for this first example, you might notice that we don't actually know where our angle is. It doesn't tell us a degree measure, but it does give us a point. So let's think about where that point would fall. What quadrant? Well, if it's 8, -6, that tells me I'm going to go 8 to the right. And then I'm going to go down -6. And that is going to be where my point is. Now, if we think about this as an angle, and in other words, kind of a triangle, those numbers right there really represent distances. I'm literally going 8 units to the right, and I'm going down 6 units here. So what we have here actually is we technically have a problem where I actually am working technically with a right triangle. So this kind of is back to one of the first days that we solved. If I'm going to evaluate any of my trig functions, in order to use SOHCAHTOA, right? Sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, tangent, which is opposite over adjacent. If I'm going to use SOHCAHTOA, I have to know all the sides in my triangle. So this is where I'm going to use Pythagorean theorem. Anytime we have a right triangle where we know 2 of the sides and not the third side, then we can set up Pythagorean theorem and we can solve. So leg squared plus leg squared, 8 squared plus, now technically it's -6 squared, but when you square any negative number, it's always going to turn out to be positive. So to solve for my hypotenuse, we really just have to add 36 and 64. Together, that's going to make 100. And to finish solving for h, we would square root both sides. Typically, this would result in a positive and negative answer. But because we're working with a length, a hypotenuse is always going to end up being positive. So our hypotenuse is going to be 10. So when I find my trig functions now that I know all the sides, I can now find their ratios. Sine is opposite over hypotenuse. So this angle right here is going to be my angle, which means -6 is the opposite. 8 is going to be my adjacent. And obviously 10 is my hypotenuse. And sine is opposite over hypotenuse. -6 over 10. Now we always reduce these. So that would reduce to -3 over 5. And that would be your final answer. Now, if you remember that cosecant is the reciprocal of sine, that tells me that cosecant is just going to be -5 over 3. Now, if you didn't remember that, you could use the fact that cosecant would just be hypotenuse over opposite. So we would get 10 over -6, which would still reduce to -5 over 3. Now, cosine, this one is going to be adjacent, which is 8 over hypotenuse. I almost wrote h, which is 10. And if we reduce 8 over 10, that's going to give me 4 over 5. Secant is the reciprocal of cosine. So if I have 4 over 5 for cosine, secant is going to be 5 over 4. Tangent, this is the last one we have to do. It's going to be opposite, which is -6, over adjacent, which is 8. And that's going to reduce to -3 over 4, which means cotangent, since it's the reciprocal, is going to end up being -4 over 3. All right. So if you need to now, you guys can now move on and you guys can start working on the homework for the day.